that we probably will do next year in the state of New York, where we also can do it at school, but it's against the other schools in New York, and they rank the schools. I've done it in another state before, and it's really fun, called the National Assessment, I think is what it's called. But I didn't get in fact, I need to make sure I get the letter sooner. By the time the letter got to my desk, because it wasn't addressed to me, the first one's like this week or in October. It was just too big of a turnaround. So, hey Anna. Math team. Morgan's supposed to be here.
Joining. That's great.
So glad you're here. You should join.
I should. I have a lot of fun stuff. You do, Anna? Yes.
Do you want to? You can sit and watch. Okay, so I'm recording now. And it's Mr. Hill turned 50 yesterday, so he's my picture in my slides. So I always have pictures in my slides if you haven't had my class yet. All right, so here was the first question, which I thought was, I want to just talk about, well, first of all, how many people did the collaboration round? I can't remember. Who was here for collaboration? Our last match. Okay. Well, maybe you'll recognize the problems, okay? So I may be using your picture some more. For math team, why not use it a lot?
It's not actually my birthday.
I told him it was yesterday. Okay, this is a great problem. And a lot of times as we maybe travel, especially to Princeton, I see these kind of questions in the fast round where you're having to answer really fast, called the quiz bowl. Find the sum of all two-digit positive integers that are 10 times the sum of their digits. I sat down to think about all of these problems last night. And at first I started to work it, and then I thought, wait, why am I going to work this problem? If it's going to be 10 times, okay, so we have two-digit positive integers. I saw all of y'all writing, which I love to see. A lot of times it's just good to kind of just start writing two-digit numbers down. So the sum of all two-digit positive integers, wait, but they're 10 times the sum of their digits. So all of a sudden I realized I didn't have to find, like, that one, what's the sum of their digits? 8. And so what's another two-digit positive integer that's 2 times the sum of their digits? I can't, well, that would be 80, but is that really what they're asking for? Okay, but then I realized it would be, how could you count them fast? 10 times the sum of their digits.
Can it only be like numbers that are divisible by 10?
Yeah, so we're talking about 10, 20, 30, 40, 50, 60, 70, 80, 90. Great, Grace. I sat around with, oh, sorry. Well, you can see the whole problem. Okay, they have to be two-digit numbers. So Grace, I sat around for a while and I just started throwing rocks at it, going, okay, what about 4 and 5? Wait, that adds up to 9, and that number is not 10 times the sum of the digits of the number they gave me. And then I realized, wait, it's 10 times that, so it's got to be, it's got to end in a 0. And then if you check it, it's true, isn't it? What are the sum of these digits? The sum of 7 plus 0 is 7, and isn't that number 10 times the sum of the digits? Okay. So how many of them are there? Are there 9? However, that wasn't the answer. So then what? What are we going to do? Huh? Say it louder. So in what way?
Like add 10.
Because it says the what? It didn't ask how many there were. So you'll get used to this. If you add up the numbers 1 through 9, you get 45. Did some of y'all know that? You knew that? Okay. This gives you 6, and 4 gives you 10. This is 11. That's up to 21. 21 and 15 is 36 and 9. Anyway, Sophie was nodding her head, saying that she knew the sum of the first 9 digit was 45. And so you're even quicker at that buzzer if you're in quiz ball. Okay? So make sure that you actually answer the question. It's the sum of all the digits, 450. It's really nice when we have a collaboration round, Diana. It's really nice when you have a collaboration round because Grace may have said it has to end in a 0, and then Sophie may have called to attention, wait, we don't want to know how many there are, because that's a pain when you hit the buzzer and you say 9, and you realize you're really answering the question right, but you didn't read the question thoroughly. So you want to make sure, like, actually, I wasn't even thinking about coaching y'all today as I was doing this. This is just something that I do when I'm working a problem. Do y'all see what I mean? So that I really got it laid out for me. All right, so they did not do that. I have their solutions, and they said a 10-digit number can be expressed as 10A plus B. And they did, it's got to equal 10 times A plus B. And you can actually solve that. I don't know. I didn't do it that way. I'm not a fan of that. I'm more of a fan of the critical thinking. Okay. I don't even really look at how I didn't do number 2 the way they did it either. All right. So number 2 is, let me get it. Number 2. This one. Okay. So. Let's see. No, I can't remember where I want to go. Pictures. Sorry, this is a. Oh, thank you. Okay. You may have seen the answer that was there, but we'll talk about it. So I don't know. I don't even remember who said they were here for the collaboration round, but just a couple of y'all. So you hadn't even thought about this one maybe. If you were here and worked it a different way, please pipe in, or if you see a different way to work it, that's what we're here for. You are not here for me to stand up here at this podium and just talk to you. In fact, if you made the other practice, there were different groups at boards like brainstorming things, and we'll do that a lot. But I felt like I don't want to just throw you to the wolves, as the saying goes, because you do need some coaching in contest math, okay, to get better at it. A cube whose length is 64. So here's a cube. Okay, and the length is 64 centimeters, and we know the edge length, and it's a cube. So these are all 64. It weighs 512 pounds. I didn't even know if that mattered or not. Sometimes you've got you've got extra information. If there are 32 congruent smaller cubes with the same density as the large cube. So all I had to make sure was that they weighed the same amount. And so it's got the same density as the larger cube, the sum of whose weights equals the weight of the large cube. Then the edge length of any one of these cubes can be written in this form, and always be sure you answer the question. It's so tempting just to find what A cube root B is, but make sure you answer the question. This is also true for SAT. I just underlined a bunch of stuff. So let me get rid of some of this. All right, there's 32 congruent smaller cubes. Congruent smaller cubes. And I know that it's got to have the same density as this. Ideas? Sophie?
I don't remember if I came off this one, but if they have the same density and like the sum of the weights are equal, then the volume is going to be the same.
Okay.
And so I think what we did was find out what the volume of the bigger cube
Good.
was.
All right, I started there.
And then divide it by 32.
Exactly. Okay.
Cube root it.
All right, so talk us through that, Sophie, why you did that.
Well,
Ow.
well, so like I said before, like they all have the same density, the same weight, so the volume's the same. And then like
So you're going to have 32 of those little cubes. Do y'all see what she's saying? It's a little harder when somebody, this is just what we've got to do today, but just to talk about it, is if you know what volume this has, you're going to divide it up into 32 smaller cubes, is basically what you're going to do. So she's going to find the volume and divide it by 32. All right, so one thing, if you don't have a calculator, I wanted to show you today, because some contests will not let you have a calculator. And so you may wonder, how am I going to get this without a calculator? Because 64 cubes is pretty big. 64 is 2 to the 6th. So I have 2 to the 6th cubed over 2 to the 5th. Again, you get used to this kind of stuff. This is 2 to the 18th, sorry. Oh yeah, that's right. 2 to the 18th over 2 to the 5th, so it's 2 to the 13th. Now, if Sophie had done, she had a calculator, so you could do 64 cubed divided by 32, and I think the number is 8,192, okay? And then you had to reduce that number, so you had to take the, well, I take the cube root of that number. You have 32 cubes, right? Y'all see she's taken the volume and divided it into 32 smaller cubes. So now I need to cube root that to find the side. Is that making sense to everybody? Okay, good. All right, so we're cube rooting that, which we can slap into a calculator, but they didn't want it in that form. It'll be a decimal. So what I did was I thought about cube rooting this statement even without even though I had a calculator sitting next to me when I was working these last night. I really just had my phone. But anyway, I know that if I take the cube root of 2 to the 12th, won't that give me 2 to the what? What's the cube root of 2 to the 12th? 2 to the 4th. And I have a cube root of 2 left. So that's 16 cube root of 2. So this is A and this is B. And did y'all see the answer was 18? Okay. All right, comments?
That makes a lot more sense because like when I did it, I was like doing like a factor tree, like
I did too on my paper. I thought about 2 different things. Like I did this little factor tree here and stuff. I'm gonna make a really funny comment on this right here. But this looks a lot like the one with the 7 factorial in it, in fact. But I'll teach you something really cool about that. Did I drop something? Oh, here it is. Okay, so I did a factor tree. But what did I do? Oh, yeah, that's like no fun because I divided that by 4 and got 2,048. I didn't want to divide it by 2. I wanted to knock into it. And then, yeah, that's just a pain, even with a calculator. So do y'all see this is really nice right here? Okay. And I'm not really sure how I would have come up with this number from actually cube rooting this number without multiple choice or something. So little coaching tip, think about powers of 2 when you see certain numbers, and you'll get used to it with me, okay? All right, now number 3 was my favorite problem in the mix. Number 3, all right, we can't see the answer. Oh, well, there's what I was looking for. Sorry. I knew I went to picture. All right. A bag contains, let A and B be, oh, this is big, distinct digits with A not equal to 0. A bag contains all 4-digit numbers of the form AB. 1 is chosen at random. The probability it's divisible by 4. Do y'all see how similar that is if you were here for the factorial problem? You should have seen Mr. Hill and I making this list after school one day of all of the factors of whatever they were wanting of, and we found a pattern, and I'm like, then I saw this last night, and I don't remember it from my previous coaching, but I hope I never forget what I'm about to show you here. So last night, I start writing this out, thinking, oh well, you know, I got 30 minutes if I'm taking the contest, and the other ones so far have been pretty easy, so, you know, maybe it's collaboration round, maybe one of you goes, hey, you know, you start writing these down, and we'll work on another problem or whatever. So it has to start with 1 because A can't be 0. So that's the first one I could think of. It can't be 1111, right? Because it's what digits? Good, Kennedy. All right. So 1313, 1414, 1515, 1616, 1717, 1818, 1919. Then I think I'm done with that because can't you? A's not 0. Oh, I could use 1010, couldn't I? B could be 0. And then 2020. I thought I wanted to get a system down. I have to skip 2022. 23, 23, and blah, 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 okay? I listed them, I thought I'm gonna find a pattern. I only went into I did the 1s, 2s, 3s, 4s, and 5s looking for a pattern. Then I went through divisible by 4. So this one is 10, let's see. Okay, so we want the number to be divisible by 4. So how am I going to figure out if something is divisible by 4?
Well, what I did was like looked at the last two digits because the first two is going to be like divisible by 100. Like if you take away the last two, then it's just like a number. Like it's divisible by 4 because it's like
Exactly.
last two zeros.
Do y'all see what she's saying? And actually, Sophie, it doesn't matter if we look at the first two digits or the last two digits because they're the same. 4's got to go into that. So here's one. That's divisible by 4, isn't it? Okay. That one's not going to be divisible by 4. That one's not going to be divisible by 4. The next one I encounter is that one. And not this one, not this one. The next one I got was 2020. Do y'all see where Sophie's taking us?
Yeah.
Okay. Then I read this, and it's super cool, okay? And then I had to go and count them all after I listed them all, similar to the factorial problem. You can take the last number that you know it goes into minus the first number you know it goes into in the range someone's given you, divide it by that number, and add 1. I still got a long way to go here, so let me show you what I mean. What is, and I'm going to use Sophie's example. I think we could actually use the whole entire number, but I don't need the whole entire number here. She started us with 12. So basically, I don't even need these parts. Are y'all okay with that? So what would the last one be in a 4-digit number that 4 would go into? 96 is the last one that 4 will go into. How'd you know that, Grace?
Because it would have to be a 9 to be like one of the last ones, and that's the like greatest number that 4 can go into is 96.
You just said that so fast, but you're right. 90. Well, and also one good help is 100 is divisible by 4, so count back 4 would also be a good way. But some people are thinking 98, 96 like that, okay? So the first one we have, the last one we have is 96 in the chain. The first one we have, divisible by 4 and add 1. What's 96 minus 12?
84.
Is that cool? I quit my list when I saw that. I don't remember where I read it, but I got 22. And then you're really frustrated when you buzz in with 22, because that's not the question. Then you're really frustrated when you buzz in with some sort of reduced ratio, because we got to be careful here. What does this find us? Multiples of 4 in that range. Okay, so there's 22 of them in that range, but what is it counting? This formula doesn't know the distinct part. So, minus 2, which 2?
44.
Okay, how'd you get that? 44 and 88, because 22 is not divisible by 4. 33 is not divisible by 4. It wasn't counting the distinct. So you got to think about it a lot, but you get better, okay? And so I've got to subtract 2, so there's 20. All right, now there's 20 out of how many? I think there's 80 of them. Yeah. How do we know there's 80 of them? How many are there of these? 1, 2, 3, 4, 5, 6, 7. Oh, wait. 8. Are there 9? There should only be 8, because you've got to count out the distinct one. Because you see it skips 1, 1. There should be 8 of these. Am I counting wrong? Are there 9? Because 0 counts. So there are 9. How am I getting 80? Oh, there's 81. Sorry, they're not 80. There's 81 of them. Oh my gosh. Hello. 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 Hello.
We're gonna come back after this.
Okay. How many are there? We've got the ones, the twos. How many? So there's 81 because how many of these? I'm going to have 9 of these 9 times, right? The ones, the twos, the threes. So I have 9 times 9. So I have 81, which doesn't reduce, so that doesn't become an issue. And m plus n is 101. This is so cool. I wanted to show you that today. It's super cool. So let's do it like on a smaller basis. Suppose I have multiples of 3. 3, 6, 9, 12, 15, 18, 21. I wasn't even counting, I'm just writing multiples of 3. My last multiple of 3 in this range is 21. My first multiple of 3 is 3, divided by my multiples of 3 plus 1. So what's 21 minus 3? 18 divided by 3 plus 1, 7. 1, 2, 3, 4, 5, 6, 7. Super fast way to count if it's a multiple of something. Okay? So let's try to remember that little, would have saved lots and lots of time from the list. Eventually you would notice a pattern. All right, so let's go to number 4. And I'm just going to write it to save time. Number 4 is, the reason I'm doing a lot of these now is they're so classic contest problems. This one I did with algebra. Doesn't have to be done that way, so a couple of you that were here, you can say what you did, so thanks for the input. Again, they want the ratio of y to x. Somebody during the contest, I've forgotten who it was, asked, like, what's a ratio? And that can be kind of tricky. Sometimes a ratio is, the odds something will happen like 1 to 3, whereas the ratio that it will happen is really 1 to 4. This is wins and losses. But usually it means the fraction, like that, the probability. All right, so I did this. Watch this. Good skill from your math team coach, okay? I don't like denominators, so my first instinct was to multiply this by y. I'm going to show you something else really cool on another problem like this. It's the first day of really coaching. xy plus 1 equals 4y. I'm going to multiply this one by y, and it gives me y plus xy equals 8y. What do you notice is in both of those? xy. And so what can I do for xy right here? 4y minus 1, so you have y plus...
But how did you get rid of the 1 over x?
Oh, I'm sorry, I multiplied by the wrong thing. I should not have multiplied that by y. What should I have multiplied this by? X. That gives me 1 plus xy equals 8x. Thanks. Okay, so then, that's okay, I got it.
Could you isolate it so the xy is on?
I'm just looking what I did. Yeah, I'm going to isolate it, but what did I do? That's what I did. Yeah, I just moved it. So I said xy is 8x minus 1. And so you get 8x minus 1 plus 1 equals 4y. So you have 8x equals 4y. And they wanted the ratio of y to x. So I'm going to divide this by x and this by 4. So the ratio is 2. All right, big deal here for contest math and SAT. Do you see I wasn't stressed over solving for x or solving for y? You've got to be looking at it from an airplane. You'll see that in the next problem that I do. You're going to be looking for a pattern or something to catch your eye. Anything in school, we're so trained to get down to the ticky-tacky, I'll solve for y.
So just make
Which
sure
can be a real big mess. It probably can be done here, but and on the SAT, it's also
Say you have
looking
this,
for
right?
critical
And you set
thinking
equals
skills,
each
so you
other,
get like 2
D,
for
F,
1
and maybe what they say.
But once I saw those xy's, I saw that I could go like this, and also
the AC
keep an eye on the big picture. I didn't have to find x and y.
Okay.
I just needed to the ratio. Here I panicked for a minute, and wait, I can't really find either one of those. Do y'all see what I mean?
That D
Okay.
equals D.
Any comments? All right, let's move right to this one. Oh, I love this problem. Okay, so this problem, and again, thank you for being patient. Big coaching day. Big picture of Mr. Hill. Let's move him out of the way. Ever. There. If only it were that easy. He's not listening to me. All right, so we have f of x. By the way, I saw where some K-pop, Korean pop star died at 24 years old. And she was a former member of the band F of X. They actually wrote it in CNN, like in the news article, like that. I thought, whoa, I should know of that band. Okay. It's a really sad story, though. I'm sorry. F of 3 equals -8. All right. When you're given points, it's always a good idea to fill them in. So I filled in -3, and I got 10 is equal to 9a minus 3b. Oh. 9a minus 3b plus c. I filled in this one, and I got -8 equals 9a plus 3b plus c. And seems like they told me something else. That's it. And the question is, what is b? Okay? All right. Did y'all see it from an airplane, this right here? They have 9a plus c. So I can say 9a plus c is equal to 10 minus 3b. So I have -8. What can I put in for 9a plus c? 10 minus 3b. That's unfortunate. What did I do wrong? Because those cancel out. Did y'all see anything? Oh, this is 10 plus 3b. 10 plus 3b, sorry. So this gives me -18 equals 6b. So b was -3. But big deal on both of those problems and again on SAT. Do you see how I'm just looking for groups of letters? Because you would get so lost in that. Like we're told in algebra class, and I've been, this year I am teaching algebra 2, algebra 2A, but I'm like, normally in class I'm like, oh, well we have 3 variables and 2 equations. Normally you can't solve that, okay? You usually need 3 equations with 3 variables. But elimination and substitution worked out really well here. Any comments on that? So I'm going to skip to number 8. Skip around. We'll just do a plain one. All right, number 8. What is the smallest positive number n such that when n is divided by 2/3, 4/7, and 5/4, the result is an integer? Sorry, I'm not screenshotting this because it's really good to see it in the words. So it says, what is the smallest positive number, because there's probably a lot of them, such that n is divided by h and you get an integer. You could start guessing chat. Ideas? You want the smallest positive number. So I was very literal. I just did this. I said, what if I take this number and divide it by 2/3, and I take this number and divide it by 4/7, and I take this number and divide it by 5/4? Hang on, Sophie. I will let you get your comment just a minute. Now I'm going to multiply by the reciprocal. All right, so remember you've got to be able to say n is divided by these numbers and you actually get an integer. So if that's a multiple of 2, I'll get an integer. If that's a multiple of 4, I'll get an integer. If that's a multiple of 5, I'll get an integer. But we need n to be able to be divided by all of these and get an integer. So what would it be? LCM? What is it? Huh? 20. Okay, because the 5 and 4 will take care of the 2. When all of these numbers go into 20, and so the least number it would be 20. There'd be lots of numbers that would do this, but the least one is 20. So did you see on that one I just reacted? You'll see as I take you to competitions, you actually see other people. There's just lots of immediate writing going on to see what starts firing in your brain along with skills you've learned. Sophie, what were you going to say there? Is there something else you did?
No.
So you did something similar?
Yeah.
It's kind of tricky to look at the 3, the 7, and the 4, you know, the way they wrote it out. You have to physically divide the n by those. All right. Let's do this one. I asked Mr. Hill about this one this morning, full disclosure. Suppose you roll 3 fair 6-sided red die. So you have these red die, and they're just normal dice with 6 sides on them. And then you have a green die over here. The probability that the number on the green die matches the least number among the 3 red dice is A to B. And they ask us, of course, what is A plus B? All right, so I'm going to roll these dice. Okay? And so say I rolled those 3 and I got that number. What's the probability that it's going to match the least number of one of those? That seemed overwhelming to me. I know if I roll 2 dice, there's 36 possibilities. If I roll 3 dice, there's 216 possibilities. And I started to kind of scratch them all out because I actually read the problem wrong. I thought it said at least something. It wants the least number. So what's the least number there? What's the probability I'm going to roll that number? 1/6. But wouldn't that always be true? Mr. Hill said the red die is a red herring. Okay, it doesn't really matter that you have 3 of them. You might as well just be rolling 1 if that makes sense. Do y'all see what I mean?
Yeah.
So suppose they're all 6s, what's the probability I'm going to roll the least number that you see? It's 1 out of 6. That, to me, I overdid that problem. So it was 1/6, and you add them together, and you get 7, which is kind of an aggravating problem. It seemed like it should be harder than that. Any comments on that one? All right, we got one more problem, then we'll go. All right, so a line passes through 5, 2, and 6, 8. And by the way, if you've taken the AMC, which some of you did last year, you can see how this is a smattering of problems that help us with that. After we finish Math Madness in the fall, we'll really zero in on doing a whole lot better on the AMC. So we'll get there. It just takes time. All right. All right, so it's a good idea just to sketch it. Read it carefully. I started finding a perpendicular line and I got the answer wrong. It says a parallel line. A parallel line through the point 5, 5. Okay. Passes through the point, parallel line passes through the point 5, 5. The coordinate where the line meets the x-axis is written in simplest form, A over B. What is A plus B? They love this, which is good training. You've got to really watch. Somebody asked what A minus B is. All right, sorry I didn't screenshot this, so let me read it again. The line passes through here. You have a parallel line that's green right here. The coordinate where the line meets the x-axis can be written in simplest form. So I felt like I had to find the equation of the line, but there's also maybe some way I could count it with slope. So let's just talk about it. I didn't try that actually. I just found the equation of the line. The slope of the red line is 6. 8 minus 2, 6 minus 5, is it just 6? Okay. And then I went and found the perpendicular slope, which wasn't helpful, okay, and found some 0 way over there. So anyway, make sure you underline things and do what you're supposed to. Then I had the point 5, 5, so I actually could write the equation of the line. If you're in a hurry, In a quiz bowl, though, this may not be the best way to work it. While you're sitting here writing the equation in a line, it's really aggravating to hear somebody hit the buzzer. Okay? But we want to be that person. We want to say, how many numbers between 0 and 1,482 are divisible by 3? You know a quick way to do it now. We'll rehearse it, but y'all remember? The last number divisible by 3, you know, those little tricks like that. There'll be some that I show you. I don't know if there's a trick here. We'll talk about it before you go. But I just said y minus 5 equals 6 times x minus 5. And if I wanted to know where it hits the x-axis, then y is 0. So I went negative 5 equals 6x minus 30. I don't remember it being 2. Yeah, 25 equals 6x. And so it's 25 over 6. And then, of course, you add them together and get 31. I think somebody would have hit the buzzer maybe by then. If this is 5, 5, and I go down 6 and over 1, though, I don't get to the x-axis. So there may be something I can do with that. I don't know. I don't know that I would have. Yeah, there is something I can do with that, with the ratio. That was pretty quick, though, so I didn't really think about that one very hard. Anybody see anything with the slope is 6? There's probably also something that going on with these 2 points that I just didn't think about because it was so easy to do it that way. But y'all see what I mean? It might be smarter to count something. But when you go down 6 over 1, you don't get to the x-axis.
So it's also really hard to like figure that out.
Yeah. But we'll see, you know, and to be honest with you, once I mean, because, you know, I coached like a big team, and they place like in the nation, and sometimes internationally at Princeton. I mean, and you can get that good. You're the same people. And so I've kind of got to remember all the stuff that I've learned before, because now it's taken me like 6 years to get here at Marymount to get this going. So, or hopefully y'all will be interested, and you'll see things and you'll share things. You'll find your own things while you're working problems that I don't know. All right, thanks so much. And Friday, I'll send out a reminder, Thursday probably, or Friday morning, that we'll have not a live match, but a match that counts on Friday. I don't know if y'all saw our score in the last one. We lost 34-21, but some of you were here when I showed how many people were on their team, like 80, and they could all collaborate. So, and they've probably been doing it for a while. So I was super excited that we had 21 points. I thought that was fantastic on this. So that was great.
Wait, so like they could like 80 people could submit?
You can divide, and then and what we should have done, I'm just still learning about this contest. What we should have done on the collaboration round when I read the things again, I think it would be best for us Friday to collaborate however you want to and all answer the same if you feel like you've got the right answer. Because that was what collaboration. I don't know why they have 5 people answer if you can collaborate. But he even said you could have fake students. I didn't understand the fake student thing. I don't know what that meant. I asked him, but I still don't understand. So Friday, I think we should do better. Y'all could collaborate.